I think we are live. Let me just quickly check my audio as well. Okay, I can hear myself. So, hi everyone, welcome to another session. So, today we'll be again solving two problems and we'll be seeing how to solve them. And I'll be giving you a few problems for your homework as well. I think there's a lot of background noise that's going on. Let me just see. So hi everyone, welcome to another session. So today we'll be again solving two problems and we'll be seeing how to solve them. And I'll be giving you a few problems for your homework as well. I think there's a lot of background noise. Okay, I think it's fine. Anyways, like if you hear background noise, I'm sorry about that. I really cannot do anything about it. I've already added some filters, but yeah, like let's actually get started without wasting a lot of time. So the first problem we'll solve is construct a tree from in order and pre-order, right? So we are given two arrays that actually tells the in order and pre-order traversal of a binary tree. What we have to do is we have to construct the actual tree from the given in order and pre-order traversal, right? So we are given the in order and the pre-order traversal and we have to construct the actual tree. So for example 1687, and finally it said that we have to print the post order, but again like the post order is already printed in the main, so you just have to worry about generating the actual tree, right? And the post like 1687, the in order is 1687, the pre-order is also 1687. So that means what pre-order means root left right, so it's 1 and in order is also 1, right? So this is the root node, right? And there is no left subtree for this. So the next is 6, so it's kind of like 1. After that on the left it is right it is 6, then right child is 7 and right child is 8, or left child is 7 and right child is 8, something like that. So we get the corresponding post order traversal. Just coming to this example, so we have 314052 as the in order and 013425 as the pre-order. So we can see that 0 will be the root node, because pre-order is what, root left right, so root is first printed, or node left right, so first 0 is printed, so 0 is the root node. After that we go to the left subtree, so 1 is the next node. After that 3 we go to the left subtree 3, and then we see that for 3 it is the first node, right? It is the first element in order, that means it is the leftmost node, so we stop here. Then the right child will be 4, so we get 4 from here. Then 2 5 will be on the right subtree, so this is how the tree would look like, right? So we are given the in order and the pre-order traversal, and we have to construct the entire tree from that. Now this is a very important interview question, like it is asked almost in like every company, so definitely this is something that you can expect to get, you might be asked in the company, right? So let's actually understand how do we solve this. So 3 1, let's write it down here. So the in order, let's call it in, is equals to 3 1, I think 314250 it was 314052, sorry, 314052, 314052. What is the pre-order? The pre-order is 013425, 013425. So it is 013425. Is it 013425? Let's quickly verify once again. 013425, yes. So how we can construct the actual tree? See, how do we construct? We start, see, what does this, what is in order? First, what is in order? We are given some node, we are given left child and we are given right child. What is in order? In order will be left node right. So first the left subtree will be printed, then node will come in, then the right subtree will be printed. So this is in order. What is pre-order? Pre-order will be node left right, node left right, so that will be pre-order. So pre-order, so see, for the root element, for the root node, we start at the root node. So the root node will definitely see in pre-order. First we print the node, right? So the root node will definitely be the first element of the pre-order. Okay, let's define this as the root node. Okay, 0. Now how do we know what is the left subtree of 0? We know 1 can be either on the left side or on the right side. How do we define the left subtree? We define the left subtree using this in order, because we know that first left subtree would come in. So till 0, like wherever 0 is, this part is the left subtree. This part is the left subtree. So we recursively construct the left subtree now. So 0, now we'll go to the left subtree. Okay, left subtree, again we'll go to the next node. So we'll go to the next node in pre-order, 1, right? So 1, what is the left subtree of 1? So left subtree of 1 will be whatever is on the left side of 1, so that is 3 in the in order. So this is the left subtree. So 1 is written here and the left subtree is this. Now we go to the next node, 3. What is the left subtree of 3? There is no left subtree of 3, because there is nothing on the left hand side, right? So we will write 3 here, and we know that it is a leaf node, so we go, because there is no left subtree, so we go back, right? We go back. What is the right subtree? There is nothing like on the right hand side for 3 as well, so 3 is just a single element, so we have nothing. After that we have 4. Okay, we have 4. Now what is the left subtree of 4? We see on this part, the left subtree of 4 will be whatever. Okay, left subtree will be of 4 is this part only, so it's kind of like happening recursively. Let me just like write down the recursions as well. I think that will make more sense. Let's just write down the recursive calls as well. So okay, so let's call a build tree method. So let's call it BT, build tree. It will give the in order the range, right? The range in the in order this. So for 0, so initially we started off at with the range 0 to n minus 1, 0, 1, 2, 3, 4, 5. So 0 to 5, right? Now when we wrote 0 here, what is the index 0 is at? So 0 is at index 0, 1, 2, 3, 3. So 0 to 2 will be the left subtree. So we will call BT 0 to 2 as the left subtree. Now we come here, 1, we write here 1. Now for 1, what is the left subtree? It is 0 to 0, right? 0 to 0 is the left subtree. 0 to 0. Now this 3, we see that it is a leaf node, so we write it leaf. That is, if this range is of size 1, in that case this will be a leaf node, right? BT 0 to 0. Now we next, so we have done with 3. So we go to 4. Now we come back, as it is a leaf node, we come back here. Now here we see that it is 0 to 2, right? So the range will be, and where is 1 present? 1 was present at index 1. So 0 to 1, 0 to 0 was the left subtree, and 2 to 2 will be the right subtree. So we'll call BT 2 to 2. And again, this is a single value, so this is the only node. So 4, we'll write it as 4 as the right subtree. We'll write 4 in the right subtree, right? And as 2 to 2, this is only representing one element, so this will be a leaf node. Now we'll again come back. So this part is completely done. So we come back again here, BT. So 0. Now we have explored the left subtree. Now coming to the right part, what was the index of 0? Index of 0 was 0, 1, 2, 3. So 4 to 5 will be the right subtree. So BT 4 to 5 will be the right subtree. So we'll go to the right subtree. Now 2, right? 2 is here. Okay, 2, we will write 2 here. Now what is the left subtree of 2? So for this, the left subtree will be, the index of 2 is 5. So 4 to 4 is the left subtree. So BT 4 to 4 is the left subtree, and right subtree is not there. So we'll go to the left subtree. 5 is left and only one element, so this is leaf node. So we'll come back. So this is the tree that we have generated: 0, 1, 3, 4, 2, 5, right? So let's actually verify if this is the answer. So we can come back here and see that yes, it is indeed the answer, right? This is indeed the answer, the thing that we have generated. So this is how we can generate the tree. Now okay, so this is how we have generated the tree. So again, like what is the complexity, right? What is the complexity? So what we are doing is every iteration what we are finding, we are recursively calling the left and the right child subtree, and that's fine, like that's kind of doing the DFS. So that is order of n into, we are also searching what is the index, right? What is the index in the in-order traversal, we are also finding that. So we are using this pre-order to construct the tree, we are using this in-order to determine whether it is in the left subtree or right subtree, or determining the left and the right subtrees, right? We are using in-order for that. So we are using in-order in in-order, we are searching for the given element which index it is present at. So we can do the searching in order of one time using hash map. If we use a hash map, we can do the searching in order of one time. So it is n into 1, so that is order of n complexity, right? We can construct the tree from in order and pre-order traversal in order of n. So let's actually write the code for this. I believe the code will make more sense. And let me know if you have any doubts, right? Let me know if you have any doubts. So let's write the code for this. Okay, build tree in, and let's call a build helper. So node star build internal, let's call it build internal, int in, int pre, and int low and int high, let's call it low and high, right? Okay, also we'll maintain one more int current pre-index, current index. Current index is for traversal on the pre-order, right? So in order we are determining the left and the right subtree, and pre-order we are like traveling one by one, right? So current index, and we'll set here current index to be equals to 0, and build internal will return actually this. So return build internal in pre, and low to high is 0 to n minus 1, right? So 0 to n minus 1 is low to high. Okay, now let's see. Build internal first is if low equals to high. If low equals to high, that is it is a leaf node. In that case, node star new node, or rather we have to always create a node. So let's just create it. Node star current node equals to new node, and current node of data equals to pre of current index plus plus, p of current index plus plus, right? So if low equals to high, we'll just return current node, because current node, and we'll also set right current of left equals to null and current of right equals to null. We'll also set these things, right? Now we return current node because we have already discussed this will be a leaf node, right? Otherwise what we'll do is we'll determine the left subtree and the right subtree, so we'll also have to maintain the hash map. So unordered map int, let's call it index, right? Index. So for int I equals to 0, I less than n, I plus plus, index of in of I is equals to I, right? Index of in of I is equals to I. So we'll get the index here, int ind equals to index of pre of, okay, index is will not do here current index plus plus, p of current index, and final at last we'll do after this we'll do current index plus plus. So current index plus plus, and here also we should do current index plus plus. Okay, current index plus plus, right? Okay, so we have done we have got the current index. Now which is the left subtree? The left subtree will be 0 to sorry, not here. The left subtree will be what? The left subtree will be low to index minus 1, and the right subtree will be index plus 1 to high. This will be the left and the right subtree. So what we'll do, we'll call recursively. So current of left current node of left equals to build internal will pass in here in build internal in will pass in pre here low to index -1 and current node of right equals to build internal. We will be passing in and pre here, and index +1 to high will be the right subtree, and finally return current node of current node will return current node, right? So this will be it. So return build internal, that should be it. So let's try to run this. Let's try to run this. Okay. We have to pass in here new node and data pre-current index. So let's pass it that way, pre-current index. And I don't think we have to do left right null, so that should be it. Okay, current was not declared in this scope. It should be current node. Okay, 1 second. So low equals to high, it should be a problem. Also, if low greater than high, in that case just return. Low greater than high, it should just return. Low greater than high, return, it should return null. Okay, so we are getting the output as expected. Let's try to submit this. So this is working, right? So this is working. So this is how we can construct a tree from in order and pre-order traversal. All right, let's move to the next question and let me know if you have any doubts on this. Let's erase this. Okay, let me know if you have any doubts on this, right? After this, we'll solve the problem merge k sorted arrays, right? Merge k sorted arrays. So what does it tell? We are given k sorted arrays arranged in the form of matrix of size k into k. So all the arrays are of size k. The task is to merge them into one sorted array, right? So we are given k sorted arrays and we have to merge them into one sorted array, and the size of each array is also of size k, right? So for example, this is one sorted array 1 2 3 4 5 6 7 8 9. So they can be merged into a single sorted array 1 2 3 4 5 6 7 8 9 like this. What about pre-order and post-order? So you have to do something accordingly. Pre-order and post-order also, I believe we can do that. So you have to do it accordingly. Like you have to use definitely you have to use pre-order to construct the tree, and post-order maybe can be used to partition between left and right child. Although I'm not sure, it should be left right node. So I think you cannot do with pre-order and post-order. In-order has to be there because in-order will partition with left and right. So pre-order and post-order will be a bit challenge. I don't think you can do that. So pre-order is always needed. Yes, you have to find the in-order. So you have to have the in-order, and in-order is needed to partition definitely. And then after that, post-order or pre-order you can use to construct the tree. So yes, if you can find in-order from pre-order, post-order, you have to find that. And after that, and if you are able to find in-order and in-order, then you should be able to find the tree as well. But I think we have to have in-order for constructing the tree. But I might be wrong, right? So I think we should have in-order always. I'm not sure. Anyways, so we have this sorted array 1 2 3 4 5 6 7 8 9. And we have to merge this into a single sorted array 1 2 3 4 5 6 7 8 9, right? Similarly, we have this 1 2 3 4 2 2 3 4 5 5 6 6 7 8 9 9. So we will merge this into a single sorted array of this, right? So the complexity expected is k square log k, right? K square log k, that's fine. Okay, let's understand this. So we have to merge k sorted arrays, right? We have to merge k sorted arrays. So let's say we have multiple sorted arrays. So हाँ हाँ हो जाएगा, मतलब देखो क्वेश्चंस जस्ट वेरिएंट सॉल्व कर लो जो भी है, एंड बाकी तो लाइक अगर तुम सारा क्वेश्चंस कर लेते हो तो डेफिनेटली लाइक उससे बाहर तो नहीं आएगा, तो लीड GFG तो कर लो डेफिनेटली. Using hips, yes, we can use hips as well, but we'll not discuss about hips, right? We'll not discuss about how can we do it with hips. Hip solution is pretty straightforward, so I don't want to discuss that, right? So we'll discuss with divide and conquer approach, because I feel that you can understand better, like, or not better actually, but you will gain more insights on how divide and conquer actually works, right? So we'll try to use the divide and conquer approach. Okay, so anyways, we are given k sorted list. So this is called list 1, this is called list 2, this is called list 3, and like that we are given k sorted list, right? Now not necessary they have to be of the same size. Here we are given that we have same size, but it is not necessary that we have to have same size, right? So we have to merge them into a single sorted list, right? So what we can do is, first is we can merge like L1 L2, we can merge into, we can maintain some L. So L equals to L1 plus L2, then L equals to L plus L3, then L equals to L plus L4, and like that will go equals to L equals to L plus Lk, right? So we can do it like this. L1 plus L2 means we are using the merge. So we are merging two sorted list, list 1 and list 2. We are merging two sorted list, and we can do that in order of n time, right? Order of n or n plus m, where n plus m is the size of the two arrays. So here everything is k, right? So this will take order of k, 2k, then this is 2k plus k, that is 3k. This will take 3k time, this will take 4k time, and like that this will take k squared time. So it is coming approximately to be k cube time complexity, right? This is approximately coming k cube time complexity, because we are taking initially L1 plus L2, like we can merge two sorted arrays in order of n plus m time. Now this will be k plus k, that is 2k, L1 plus L2. Now L is of size 2k, so 2k plus k, that is 3k, then 4k, and like that k, so k square, k square plus k square. So if you add them up, the total complexity will be the addition of all of them. So it will be k plus k up to k into k, rather k into k, like this. So it will be k into k plus 1 by 2, 1 plus 2 plus 3 up to k. So that will be a k cube, right? K into k square, that is k cube. So the total complexity will be k cube, like this. If you take two arrays and merge them like this, right? So we have to definitely do better than this. We cannot use k cube. So the idea is pretty simple, right? So we are given k sorted list, L1, L2, L3, like that. Let's call it Lm, and after that Lk. The idea is pretty simple. We will do divide and conquer, that is, we'll break it into two parts, L1, L2 up to Lm. The second part will be m is the mid, Lm plus 1, Lm plus 2, Lk, and we will try to merge them, right? So this should return the single sorted array, that is the merging of these. This should return a single sorted array, that is the merged result of this. Now we'll proceed like this, divide and conquer way. So similarly L1, L2 something, and then something remaining up to Lm. Similarly this is also divided into two parts, and again divided into two parts. Till we have L1, L2, L3, L4, like that up to Lk, right? So till we have this, we will keep on dividing into two parts, right? We'll always keep on dividing into two parts. Now let's understand the complexity, right? So at this level, what is the complexity? It is k plus k, 2k plus 2k plus 2k, like that. How many k by 2 pairs are there? 2k into k by 2, k by 2 pairs are formed, so that is k. At this level it is k. Similarly here also it will be k. At this level how much? See, it is of size k by 2. So k by 2 plus k by 2, that is k again, and this is also k. So at every level it is of complexity k. At every level it is of complexity k. How many levels are there? At every branch we are doing, we are decreasing the size by k by 2, right? And we'll go up to 1. So k by 2, then this will be k by 4, and like that will go up to 1. So how many steps are happening? Log of k, right? And k log k, this is the this should not be the total complexity. I think I made some calculation mistake. Let's actually do the calculation again. System design, I'm not sure if I'm allowed to teach system design here. I'll have to ask L1, L2, L3, but I'll definitely ask, like I definitely want to teach those things, so I'll definitely try to get something done on that. Anyways, so here what's happening? So L1, L2, it is getting divided into the first half, and then the remaining part up to LK is the second half. Then like this it is continuing. How long is it continuing? Finally there will be L1, L2, like one child L2, then L3, L4, like that up to LK minus 1 and LK, right? So this will be, here there is no complexity. Here we are merging 2, so it will be k plus k, 2k, 2k plus 2k, like that up to k by 2. So k, this is k squared. It will be 2k into k by 2 pairs, right? So 2k for each merging, L1, L2 merging will take 2k amount of time, and there are how many pairs? K by 2, so it will be k by 2 into k by 2, so it will be k squared, right? So k squared at this level, k squared at this level also, because why? Because you have, what is the length here? The length will be k into k by 2. Why k into k by 2? Because you have k by 2 arrays and each of size k, so this will be k into k by 2 and plus k into k by 2 again, so it will be k squared, like this. So k squared, and like this it will go. So it will be k squared at every level. And how many levels are there? There will be log n levels, because see, here we are dividing, we had k arrays, here we'll have k by 2 arrays, after this we'll have k by 4 arrays, and like this eventually we'll have one array. So every time it is decreasing by a factor of 2, so k squared into log k will be the total complexity. So the total complexity will be k squared into log of k, k squared into log of k. So the it's simple actually. How we do we want to do this? In fact, it doesn't even, yes, at every level it is k squared. So even we do not have to like have equal sized arrays, right? So the logic complexity is simple. So let's say we are given merge k, and we are given k arrays, right? So k arrays, so let's call it vector int arrays, right? We are given k arrays. So here we are merging low to high, int low to high, so we are merging index low to high. So what we'll do first, we will merge, so we'll find the mid equals to low plus high by 2, low plus high by 2. So first we'll merge k up to mid, so we'll merge up to mid, so ARR low mid, we'll merge k from mid plus 1 to high, so ARR mid plus 1 to high, and finally we'll have the merge operation written. Merge will merge two sorted arrays, so we'll finally merge this, let's call this left, let's call this right. So merge will finally merge the left and right. So this should be the pseudocode, right? This should be the pseudocode. We have k sorted arrays. We are taking the current range we'll be merging is low to high. These many arrays will be merging. So we'll find the midpoint. We'll merge the left part into a single array. We'll merge the right part into a single array. Finally, we'll call merge on left and right. We'll finally call merge on left and right. All right. So this is the this is the final pseudocode. So let's try to write the code for this. So merge k arrays int k. So let's write here vector int underscore or merge k, let's call it merge k vector int arr low to high. So if low equals to high, return arr low, will be directly returning arr low. Else, and if low greater than high, we will return a empty array. So we'll return an empty list, vector int, return vector int. Else, int mid equals to low plus high by 2. So vector int left is equals to merge k, will call arr low and mid. Vector int right equals to merge k arr mid plus 1 to high. We'll merge these two parts, and finally we'll do what? We'll merge two of them. So merge two, left right. So we'll have to define merge two as well. So merge two is the simple merge operation. So vector int merge two, vector int a, vector int b, right? So how do we do that? So vector int res int pos1 equals to 0, pos2 equals to 0. So while pos1 not equals to a dot size and pos2 not equals to b dot size, we'll check if a of pos1 is less than b of pos2. In that case, res dot pushback a of pos1 plus plus, else res dot pushback a of pos2 plus plus, right? And finally we'll have the other two conditions, like if one of them is completed, the other one will be not. So pos1 less than a dot size. So instead of not equals to, we can tell less than, and here also we can tell less than. Pos1 less than pos2, res dot pushback a of pos1 plus plus, and while pos2 less than b dot size, res dot pushback a b of pos2 plus plus. So finally we can return res, and this will be merged two of them, right? So here what we can do is return merge k arr 0 k minus 1. So that should do it. Let's compile and run. How k square at each level, I'll explain again. So let me just submit this. One second. 57 81 63. Okay, repeat कैसे हो गया? 57 81 कोड गलत लिखा क्या? Let's see. Low to mid, low to high. Low equals to high हुआ तो यार low return करो. Mid equals to low plus high by 2 return करो. Merge k is low to mid. Merge k arr mid plus 1 to high. Then merge 2 will be left and right. So merge 2 will be taking 2, pos1 equals to 0, pos2 equals to 0, while pos1 less than a dot size and pos2 less than b dot side. If a of pos1 is less than b of pos2, res dot pushback a of pos1 plus plus, else res dot pushback a of pos2 plus plus. Now while pos1 is less than a dot size, res dot pushback a of pos1 plus plus, while pos2 less than b dot size, res dot pushback b of pos2 plus plus, return res. मर्ज 2 तो सही लग रहा है. मर्ज इसमें क्या प्रॉब्लम है? ए आर आर लो हाई. लेट्स सी 5781. पहले 5781 पे रिकर्सिवली कॉल होगा, 6371 पे रिकर्सिवली कॉल होगा, फिर 57 पे कॉल होगा, 81 पे कॉल होगा. सो 57 शुड रिटर्न दिस ओनली सिंगल एरे 57. सॉरी, we have two arrays, right? 5781. So we have 2, k is 2. So we have two arrays. 5781 is the first array, 6371. So first of all 5781 will be returned, then 6371 will be returned. So let's write some debug statements, see out, and also let's add this as the custom input. 2 5781 6371. Compile and run. Let's run this. We'll add a few debug statement to check. Okay, 57. So see out low high ender. So there should be 0 to 1. Okay, so there should be only two recursive calls, 0 0 1 1 and 0 1. So low high will be okay, 0 to 2. How 0 to 2? Oh, okay, not this one. So let's run this. So 0 1 0 0 and 1 1. So 0 0 will return ARR low, 1 1 will return ARR 1. Okay, so we have returned we have two of them. So then this will be the merge 2. Let's call it C out. We cannot do C out, so C out left is for int v belongs to left C out v, and C out endl. Similarly, right, for right also will do the same thing. This will be right is, and v belongs to right, and C out v. Okay, let's run this on the test case. So left is 5781, right is 6371. So this part is correct, then merge 2 is failing somehow. So merge 2 we are taking vector int res pos1 equals to 0, pos2 equals to 0 initially, while pos1 less than a dot size, yes, and pos2 less than b dot size. So if a of pos1 less than b of pos2, if a of pos1 is less than b of pos2, res dot pushback a of pos1 plus plus, else res dot pushback a of pos1 is less than b of pos2, yes, so pos1 or b of pos2 plus plus, my bad, so b of pos2 plus plus, and now it should return the answer correctly. So let's remove the debug statements. So let's try to run this on the custom case. Okay, it is giving the correct answer. So yes, I am explaining the complexity analysis again, how it's k-log n. Okay, this is working. So I believe there is no problem with the code. The code is pretty straightforward, but let's actually quickly understand the complexity, right? Again, so see, we have L1, let's consider 8, L3, L4, L5, L6, L7, L8, right? Let's consider 8 of them. So first we'll partition them into L1, L2, L3, L4. Then we'll partition them into L5, L6, L7, L8. Now we'll partition them into L1, L2, L3, L4, right? L1, L2, L3, L4. L5, L6, L7, L8, and finally they will be partitioned into L1, L2, L1, L2, L3, L4, L5, L6, L7, L8. Okay. Now here, see, just consider this level, right? Consider this level. What's happening here? We are merging. What is the size of L1? What is the size of L1? Let's say each array is of size 4, right? So L1 is of 4 units, L2 is of 4 units. So how much time does it take to combine L1 plus L2? So it will be 4 plus 4, that is 8 units of time. L3, L4, it will again take 8 units of time. This will also take 8, this will also take 8. So the total time taken, it will be 8 into 4, 32, right? Okay, 4, 4. Each of them will be of size 4. No, each of them will be of size 8. Sorry, my bad. Each of them should be of size 8, right? Or let's assume each of them is of size k. Just let's assume each of them is of size k. So this will take, this is of size k. So it will take 2k time. So this takes 2k time. This also takes 2k time. This also takes 2k time. This also takes 2k time. So it will be 2k, 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 right? So how much? 2k into 4? 8k. And actually it is k is equals to 8 as well. So because the size is here, so 8 square. K is 8, so 8 square it will be. Similarly here at this level also there are these many elements, there are k squared elements, so it will be again like k arrays each of size k, so k squared elements, so again it will be 8 squared. At this level, what is the size of this? This size will be 2k, that is 16. This is of size 16, this is of size 16, this is of size 16. So how much the time does it take? 16 plus 16, 32. This will also take 34, that 2, that is 64, that is again 8 square. So at every level, and finally this will return 32, 64. So what is the total complexity? See, at every level it is 8 squared plus 8 squared plus 8 squared, where 8k equals to 8, right? So it is 8 squared at every level. And how many levels are there? Log n times. Log n, that is log of 8 times. So the total complexity will be 8 square log of 8, right? Or general k square log of k. This will be the total time complexity, right? All right, anyone has any doubts on this? Any doubts that you have? Otherwise, let's look into the homework as well quickly. So for homework, you will be doing pretty easy questions. Reverse first k elements of the queue. So you are given a queue, you have to reverse the first k elements. Second is binary heap operations. So you have to write the operations for a binary heap, like extract, min, delete key, and insert, and those things. So this is good to be practiced, because again, like in the interview, you might be asked to implement a binary a heap or a priority queue. So do this. And finally we have minimum cost of ropes. So this is basically, there are given n ropes of different length. We need to connect these ropes into one rope. The cost of connecting two ropes is equals to the sum of their length. So your task is to connect the rope with minimum cost. This is also a very easy question. Think about it, how do you want to connect so that you get minimum cost, right? So this will be a priority queue based question, just a hint. Try this, and yep. So these are the questions for your homework. Make sure you do them, and I'll be seeing you in the next class. All right.